all through how to detect cycle in a linked list. It's an easy lead code problem, and it looks like it's been asked by Amazon, Apple, and Bloomberg. This is a very common problem, and once we know how we can solve this problem, we can apply the same algorithm to other variations of this problem that are medium lead code as well. So let's look at what a cyclic linked list means. By this example, we see that the last node is pointing to one of the nodes before it, creating a cycle. Whereas for a linked list that doesn't have a cycle, this last node would point towards null. This problem is solved by Floyd's cycle detecting algorithm, and I've made some graphical representation of to list with a cycle and list without a cycle, and I'll be walking you guys through applying this algorithm and how it behaves step by step in this video. So first thing is we initialize two pointer at the head of the list. So let's say we call them slow and fast pointer. Now let's initialize them at the start of the head for both the linked list that has cycle and that doesn't have a cycle. Then after first step 2, we move slow pointer 1 step ahead and fast pointer 2 steps ahead, and we continue doing this until fast is not null and fast.next is not null. As soon as fast is null or fast.next is null, then we just exit out of the loop and return false. However, while we're still in this loop, while this condition is still true, and we find that slow pointer is equals to fast pointer, then there is a cycle. And for step 3, if the loop exists, then we simply return false. Now let's have a look at applying this step 2 for both the scenarios bit by bit. So we move slow pointer from 1 to 2 for both the lists, and fast pointer from 1 to 3 for both the lists. It's moving 2 steps ahead, 2 nodes ahead, whereas slow is moving 1 node ahead. We repeat the same thing, and slow will go from 2 to 3, fast will go from 3 to 5 for both the lists. But one thing to notice for a list without a cycle is that when fast reaches 5, that's the end of the list, its next is null. And as soon as it's null, the loop exists and we return false. And that way, this algorithm is correctly detecting a linked list without a cycle. Then but for linked list with a cycle, we continue doing the same thing. We move slow from 3 to 4 and fast from 5 to 3, 2 steps ahead. And then we do the same thing again. We move slow from 4 to 5, fast from 3 to 5, and they're both at the same node. And when that happens, we return true, indicating that a cycle has been detected. Now let's look at the code. There's a method that returns boolean, and it's called hasCycle. It takes in the head of the list, and then we initialize both slow and fast pointer to the head of the list. And then we check if fast pointer is null or the next of fast pointer is null. And then inside the loop, we move slow pointer by 1 node, fast pointer by 2 nodes. And if at any point both of them are equal, then we return true. However, if this loop breaks and exits, then we return false. That's the code. It's very short and simple. Now let me submit it. Even though I've already submitted it, I'll submit it for the sake of this video and see what the performance is like. Okay, so the performance is pretty good, and then we can see that it beats 100% of the solutions implemented by Java, which means that this algorithm is pretty good. That's all. I hope you got something from the video. Thank you.